Hi everyone, my name is Rajiv Lochen. I work as a cloud engineer with PolarSeve in the consulting team. I help my clients build, migrate, and modernize their applications and workloads on the AWS cloud. Today I want to talk about FSx for file share on Windows EC2 with mapping. Some introduction to FSx for Windows File Server. FSx provides a fully managed Microsoft Windows file server backed by a fully native Windows file system. It supports the industry standard server message block protocol to access the file storage over a network. FSx is a managed file system, so it eliminates the need to set it up and provision the file servers and storage volumes, and the updates and hardware failures and backups are taken care in the backend by AWS. FSx file storage is accessible from Windows, Linux, and Mac OS computer instances, and also devices running on AWS such as EC2 and Upstream and Workspaces and the VMware Cloud on AWS can access FSx file storage. Network connectivity to the FSx file system is through in-VPC access, VPN, direct connect, VPC peering, or through transit gateway. Some of the core concepts of FSx for Windows File Server is file system, file server backups, and file shares. File system is, as you know, where you store your files which you want to access, and where there's one or more Windows file servers and storage volumes in a file system. Storage capacity and throughput capacity can be defined when you create a file system. Backups with FSx is consistent and highly durable and incremental. It uses volume shadow copy service in Microsoft Windows, and automatic daily backups are turned on by default. File shares is another concept wherein FSx comes with a default Windows file share when it is deployed with a /share is the default share. It's basically nothing but a specific folder which is created when the file system is deployed. FSx itself can be accessed through a DNS name, or you can create a DNS alias in Route 53. Some of the native Windows compatibility features for FSx include support for NTFS. It supports native SMB 2.0 to 3.1.1. It supports DFS namespaces. With DFS namespace, you can group your file shares from different file systems onto a single namespace and present that to your clients. In the image, you can see that there are different FSx file servers deployed and a file share against each of them. And there is a common namespace example.com/cop, which is presented as a single file set to the clients. FSx also integrates with Microsoft AD and supports Windows ACL. Provides fast and flexible performance. It's built on SSD storage and provides high throughput and IOPS. FSx file system, you can deploy that in basically two modes, two options, as a single lazy or a multi-AZ. And the image, you can see that it's deployed as a multi-AZ architecture with the connectivity to on-premise network using Direct Connect or VPN. When you deploy FSx in a single AZ mode, it continually monitors and addresses hardware failures. It also replicates data within the AZ. But when you deploy it in a multi-AZ, apart from monitoring continuously and replicating data within AZ, it also replicates data across AZs and automatically fails over if there is a AZ or a file server failure. Replication is continuous and it's synchronous when you deploy that in a multi-AZ file system. FSx supports SQL Server HA deployments. Amazon FSx is optimized for shared storage for SQL Server databases by supporting continuously available shares. It uses databases and logs for SQL Server, always on FCI deployments. Some of the events which trigger a multi-AZ failover is if the AZ itself fails or if the file server fails, the AZ failover is triggered, and the file server in one AZ will automatically fail over to the other file server, another AZ, and this happens in the background, and there is a DNS switch which happens. FSx also supports file level restore for end users, shadow copies basically. So if you want to restore a specific file, which can be done through the previous versions tab, as you can see on the image, and you don't need to restore the entire file system. It's basically self-service, and you can compare previous file versions as well. It provides high performance, less than 1 millisecond latencies, and multiple gigabits of throughput and thousands of IOPS. Throughput capacity is one factor which determines speed at which the file server hosting your file system can serve the file data. So FSx offers high levels of throughput, but also comes with higher levels of IOPS and more memory for caching of data. So throughput capacity can start anywhere from 8 Mbps, which can be defined on FSx, and you can set up to 2 gigabits per second. And burst throughput can start anywhere from 192 MB per second to 438 MB per second. FSx offers sub-millisecond latencies with SSD storage. You can get up to 3 gigabit per second of throughput and hundreds of thousands of IOPS for file system when you try to access FSx directly, the file server. And you can get up to 10 plus gigabits per second of throughput and millions of IOPS when you use client-side caching. As I said earlier, throughput capacity can be set by yourself, or it can, when you deploy an FSx file system, it's automatically recommended by FSx itself, as you can see on the screen. But there is an option to also specify the throughput capacity. You can set the minimum storage capacity to be set is 32 gig, and it can go up to 65536 GB per second, GB byte. Online throughput and storage capacity scaling. So FSx supports online storage and capacity scaling. There are two options available on the image. As you can see, you can update the storage capacity and throughput capacity. You can define it as a percentage or an absolute value. Percentage, it should be in increments of at 10%. And throughput capacity can be changed online as well. Some of the storage pricing per GB per month for FSx is for a single lazy for a SSD based storage, you have to pay for a Sydney region, it's 0.156 cents. And for multi-AZ, it's 0.276 cents. FSx supports data deduplication. So for large data sets, we often have a lot of duplicated data, which basically increase storage costs. So we want to reduce that cost. So FSx supports data dedupe. Once it is enabled, you save up to 50 to 60% of your costs. Once data dedupe is enabled, you can see the pricing is halved, and for SSD-based storage for a single AZ, it's 0.078 cents, and multi-AZ, it's 0.138 cents. FSx integrates directly with your organization's Active Directory, whether it is on-premise or in cloud. Users can continue to access file shares by authenticating with the existing credentials, Active Directory credentials, or they can migrate and use their existing. You can migrate and use the existing files and folder ACLs and share level access control. And how do we migrate is using Windows native tools like Robocopy, and it will still preserve the existing ACLs, but you can also now FSx supports AWS data syncs to migrate data from on-premise to FSx. Some of the AD integration options which is supported is AWS managed Microsoft AD and self-managed Microsoft AD, which is deployed on-premise. How do we administer FSx file system once it's deployed? So administering FSx file system can be done using remote PowerShell and some of the features which can be configured: SMB file shares, shadow copies, data deduplication, user quotas, and open session files. And you can also encrypt in transit and can enforce that. The image illustrates Windows PowerShell command, which is run to connect to the FSx using a remote PowerShell endpoint. It is good to note that remote PowerShell endpoint is different from the DNS endpoint of FSx itself. So you can see there is some get commands which is run to get SMB shares, sessions, and share access. FSx also integrates with different AWS services such as IAM, KMS, CloudTrail, CloudWatch, and Workspaces. How do we enable FSx? It can be enabled from multiple ways through either console or API or CloudFormation. And there are some links there to deploy FSx and automate it through using CloudFormation templates. The image there depicts or illustrates the creation of FSx through console. As you can see, when you create a FSx file system for Windows file server, you have to define your Windows file system name, and deployment type has to be chosen, whether multi-AZ or single AZ. Storage capacity needs to be defined. Throughput capacity is automatically chosen as recommended throughput capacity, but you can also specify the throughput capacity. Windows authentication needs to be chosen, and that can be a managed Microsoft AD or a self-managed AD on-premise. Again, talking about enabling FSx for Windows file server, it can be deployed or automated using CloudFormation. So the extract on the image on the right is a CloudFormation resource type AWS FSx file system, which is deployed through CloudFormation template, and some of the parameters which is passed. You can parameterize many of the properties. So one such is Active Directory ID, as you can see there, and also storage capacity. Once it's deployed, how do we manage FSx? So it needs to be managed through management service console. So you'll have to just run fsmgmt.msc, and it will open up a screen like that on your left. You can see all the shared folders there. And you can see there is a default shared folder called share, where you can store all your shared files once you're migrated from on-premise. But you can also create additional shares and create additional folders. You can also see sessions and open files within the management service console. How do we map FSx on EC2 instances? You can map FSx file share on EC2 Windows instances by using a Windows File Explorer. As you can see on the image on the right, it's mapped as an UNC path with the DNS name of the FSx file server and the share name, which is share, it's a default share. But you can also map it as a command prompt. Through command prompt, you can use netuse with a persistent flag. You can mount an FSx for Windows file server file share on EC2 Linux as well, if that EC2 instance is either domain joined or not domain joined, but FSx file shares can be mapped to it. In order to do so, we'll have to install sys utils. You have to create the mount point directory and authenticate with Kerberos and mount file share. The last point is just the command which is run sudo mount to mount the sys sys share to the Linux instance. And the image on the left is the VPC screen. Basically, illustrates the DNS name and the IP address of the FSx file server and the remote PowerShell endpoint. As you can see, there are the DNS name and the remote PowerShell endpoint is different, although it looks similar. It's a different endpoint. Some conclusions on FSx file server on Windows. FSx has helped our clients able to provision storage to each of their applications independently at scale and store shared files for the data management system. AWS FSx for Windows file system is also allowed our clients to connect from Amazon workspaces, which provided them a smooth transition from on-premise to AWS cloud with fast, secure shared storage to company files. And AWS FSx has also assisted clients to have a highly available, high performance Windows file system, which has reduced their maintenance and management costs while integrating seamlessly with their existing systems.